Let me show you how to test an electric motor. I have this electric motor, but I don't know if it works. I don't want to just plug it in the wall socket because it might be damaged inside, it might burn away and cause some damage, or even my fuse could blow up. So I'm going to try and test if this electric motor works before I plug it in my wall socket. So first thing to notice is that this electric motor has a capacitor. So that means this is a single phase electric motor. And since I live in Europe, at least this part of Europe uses 230 volts AC. I am pretty sure that this is also a 230 volt unit. This motor doesn't have any plates on it that might suggest that this is a one phase 230 volt motor, and I don't even know how much current does it draw, but this is a pretty beefy motor. So let's just try and test it, and we might as well plug it in a wall later. Okay, this is where the motor is connected to the wire that should go to the wall socket. We are going to disconnect the wire because I want to test the motor, and any moisture in this wire can mislead me from my tests. I'm going to show you what I mean by that. I have removed the cut wire, so now from here we can already do some tests with our multimeter. First I set my multimeter in the ohm position. I'm going to check for the resistance. So my meter shows 5.3 ohms, which can be correct, and it is important to check if it has any connection between these wires and the motor housing, which is grounded, and it doesn't. That means that the motor winding did not blow and short out to the case. Okay, this is usually how a single phase electric motor is connected. This is our live wire, this is our neutral, this is the main motor winding, this is the secondary winding that is used to start up the motor, and this is our capacitor that is connected in series with the secondary motor winding, which is connected in parallel with our main motor winding. So that means these connections here are these connections here, and we know that one of these wires goes to the live and one side of the main winding, and the other side of this capacitor goes to the secondary winding, which then goes to the neutral. So let's disconnect the capacitor here. Okay, now we want to check, based on this wiring diagram, we want to check if our windings are still intact. This is our capacitor connection points, which are this one and this one, because capacitor is connected in series with the secondary winding. But if we connect our multimeter between here and here, we should get 0 ohm reading, which is right here, I think. There we go. So these two connections are the same. As you can see, between this is 0 ohms. And now we can check between here and here. That means since we don't have a capacitor anymore, this means we are going to check our primary coil, which is this one. So our primary winding has 5.5 ohms. Let's find out how much our secondary winding has by connecting our multimeter between this point and this point. Then we are measuring right here. So I have 3.3 ohms. 3.3. So you can see that we have 3.3 ohms on our secondary coil and 5.5 on our main coil. And actually we can measure them together by putting our multimeter here and here. So you can see that the multimeter will measure through here, and it should be combined there you go, 8.5. Close enough, but my meter isn't an expensive one, so combined these two coils have 8.5 ohms. Based on this, I think we are ready to connect the motor to the wall socket, because the resistance is good. If the motor is faulty, it would either be an infinite resistance, or it would be shorted to the case, or it would be some kind of odd number in, let's say, kilo ohms. But since the resistance is this low, this probably means that we are measuring through the windings and getting the result we actually want. Okay, there. I have connected this temporary plug. I need to change this because it doesn't have any switches, but I will use this switch here to power it on and off, just to check if it works. Another thing that I forgot to mention is that the value of the capacitor could tell us something about this motor. Let me show you. It says motor starting capacitor. So this is not a running capacitor. This is a high capacity, high microfarad capacitor, which means somewhere inside is a centrifugal switch that disconnects this secondary winding. So let me show you how that is connected. Okay, so you have your live and neutral like before, and you have your main winding here, but this time this is the capacitor. This time you have a switch. You have a centrifugal switch that is actually in a closed position normally. Right now, when it's turned off, it's in closed position. So when you apply power right here, for the moment until the motor spins up, the centrifugal clutch disables this secondary winding, so it doesn't run all the time because it is not needed. So the value of the capacitor showed us that this motor doesn't have a running capacitor but rather a starting capacitor, and it gets turned off in this motor when it winds up. So I'm going to demonstrate it to you if this motor actually works. I hooked it up, so let's see if it actually works. It looks rusty, but it should, if it works, it should turn. So you can see that it works, it turns. It was kind of shaky, so you might have missed it. Let me just bring the camera up. Okay, I have put some electrical tape so you can see it better. It does work, and it is turning kind of slow, which means this is a 1400 RPM motor, which is great. It is more useful to me than a 2800 RPM motor. So let's check it out again. Oh, and can you hear the centrifugal clutch engaging when the motor turns back off? Listen carefully. You can hear that click sound, which means when the motor is about to stop, it engages this centrifugal switch, then it is ready to turn back the secondary winding on. Having a centrifugal switch means that this motor was probably used in the high starting torque application, something like a drill press. Drill press usually needs a higher starting torque because you want to spin up everything. So you can actually hear the centrifugal switch disengaging. Did you hear that click sound? That means that that motor has the exact same switch, centrifugal switch, as this one. Okay, so the point here is to measure all the resistance in the main and the secondary winding. Make sure that they are actually in function, not burnt or not shorted to the case. You can check the capacitor if it has any. If it doesn't have, you can check if it is a three-phase motor. Three-phase motor usually have 6 connection points here, and three-phase motor doesn't have this secondary winding. I hope this video actually helps someone test their motors if they are not sure if the motor is actually in a good condition. This motor needs to get its bearings changed and refurbished, repainted, but all in all it is a good motor. So thank you guys for watching. Subscribe if you want to see more videos like this. You can check my last video where I restored this drill press, and you can press the bell icon. Please press the bell icon because my videos are not seen by my subscribers because of weird YouTube algorithms and stuff like that. So you can press the bell icon and you can leave me a comment down below if I'm making any mistakes here. I don't have a degree in this field of work, but this is some common knowledge, I guess, that I want to share with you. So thank you again for watching, and I'll see you in the next one.